A popular interview question concerns the four core concepts in object-oriented programming. These concepts are abstraction, encapsulation, inheritance, and the polymorphism. Before considering what they mean, first consider what is a class and what is an object. A class is a template for creating objects. Class is written by a programmer to define the attributes and operations of an object. Attributes describe the object. They are sometimes referred to as fields because they contain data. Operations are actions that can be done to or performed by the object. They are sometimes referred to as behaviors, but more commonly they are known as methods. In the realm of object-oriented programming, an object is anything of interest to the software application that you are building. It's anything that you want to store and process the data about. Another name for an object is an entity. Here we have an animal class that has few attributes as well as methods. Using this animal class, we can create many animals, such as a dog, a cat, or a buffalo. Each of these objects contains data that describe the animal that we have created. Now we have an idea about the classes and objects. Let's look at each of the above four concepts. This leads us to the first fundamental concept of object-oriented programming, namely abstraction. Abstraction means to simplify the reality. Through the process of abstraction, a programmer hides all but the relevant data about an object in order to reduce the complexity and increase the efficiency. Let's try to understand this concept with examples. First, look at this slide. We have too much information here. But with the concept of abstraction, we only need to know about this is a lion, not too many details of it. Then we can hide all the irrelevant data, but still we know this is a lion and it will behave as a lion. Another example of this concept is a behavior of a mobile phone. A mobile phone only exposes a few things to the outside world, such as the power button, volume button, charging input, and so on. We don't need to think about how it's making calls or how the charging happens under the hood. With the abstraction, rather you would only concern yourself with the data that are relevant and the task that you want to perform with those data. The second fundamental concept of object-oriented programming is encapsulation. This refers to the bundling of data along with the methods that operate on those data into a single unit, such as a capsule. A Java class is an example of encapsulation. We have attributes that are relevant to the class inside it. Then we are performing actions on those data and we are bundling all these in a single unit. The third fundamental concept of object-oriented programming is the inheritance, which means that a class can derive its methods and properties from another class. Inheritance can result in a hierarchy of classes. For example, this animal class defines the methods and properties of an animal object. A dog is also an animal, so through the inheritance, the dog class derives the methods and properties of the animal class. A cat and buffalo are also animals, then they are allowed to derive the methods and properties of the parent class. A child class can have some extra properties and methods of its own. A cleaner inheritance defines the type of relationships. The class at the start of the inheritance hierarchy is called the superclass. Any class that derives from another class is called a subclass. The final fundamental concept of object-oriented programming is polymorphism. Polymorphism means that a class can implement an inherited method in its own way. We know that animals can speak, but every animal speaks in its own way. For example, dogs are barking. We use method overloading and method overriding to achieve polymorphism. Here, in each three subclasses, we have to override the speak method to allow animals to speak in their own way. Hence, polymorphism literally means many forms. To recap the fundamental concepts of object-oriented programming, abstraction means simplifying the reality and focusing only on the data and processes that are relevant to the application being built. Encapsulation means that data and the actions that manipulate those data are bound together and their complexity is hidden. Inheritance means that a class can derive its methods and properties from an extensive hierarchy of superclasses and subclasses. Polymorphism means that different subclasses of the same superclass, which therefore share the same interface, can implement those interfaces in their own ways by overriding the code of the method they inherit.